All right, now we're going to do net ionic equations. We're just going to do 1, 2, 3, and 4 here. You did this lab. These all created precipitates, and we're going to just talk about what that actually means when we write a net ionic equation. So I start with the first one, Ki aqueous, okay, plus Pb NO3 aqueous. Okay, it made two things. So this is a normal double replacement reaction. Okay, so that would be PbI2. Okay, that has to do with charges. Pb is plus 2, I is minus 2. I put an aqueous there, but I was just assuming things. I'm going to stop that. Plus KNO3. I got to check my solubility rules. Okay, PbI2. Well, I have I. I is soluble except for with Pb, so this is a solid. And KNO3, NO3 is soluble all the time, so that means this is AQ. Here's the deal. A double replacement reaction doesn't happen unless a solid, liquid, or gas is formed. So we do have a solid, and this is the bad boy. All the aqueuses break up into pieces. They all do, okay? They break up into their ions. Now, if I were to balance this, and I'm going to do this, I'm going to put a 2 here, I'm going to put a 2 here, and we're all balanced. Every one that's aqueous breaks up. I don't have to do my net ionic like this, but I'm going to show you what this means. This means I have 2 K plus aqueous, okay? As soon as it gets in the water, breaking down, plus 2I minus aqueous, okay? It's breaking down, it's breaking into its parts, plus Pb plus 2 aqueous, okay? Plus, how many NO3s? 2 of them, okay? You don't put the 2 at the end. It's NO3 and its charge is minus 1. Aqueous. There were too many people on the test who did not put charges on a net ionic equation. You need charges. All right, but here's the deal. The solid doesn't break up. PbI2, solid. Plus, all right, here it's aqueous, so it breaks up again. I have 2K plus aqueous plus 2NO3 minus aqueous. Okay? The stuff that's on both sides are considered spectators and they don't count, okay? So I can get rid of this and I can get rid of this and I can get rid of potassium and potassium. Everything else is what's left over for my net ionic equation. That's what's actually doing the reacting, okay? The other stuff is just hanging out in solution, okay? So this is your net ionic equation. That's all that is. If you don't have the charge, if you don't have the state of matter, it's not right. All right, I'm going to do a next one, and the next one I'm going to do, I would like to do it without showing all of that work. I'm going to show you my little trick. So our next situation, actually, I'm going to skip. I would like to do Na2CO3 with iron nitrate here. Okay, I'm going to do number 5. All right, so number 5, okay, would be Na2CO3 aqueous plus FeNO3 aqueous. And that made a precipitate. All right, I don't know which one it is, but I'm going to have Na with NO3. That's, oh, I know that's aqueous because NO3 is always aqueous. Plus Fe, and it has a charge of plus 2, CO3. And I have to figure out if that's a solid or a liquid or aqueous. So I'm going to do here CO3. And it says insoluble. That means solid, CO3, except for with alkali metals or ammonium. That's not ammonium or an alkali, so this is a solid. So ladies and gentlemen, that's the full reaction, except, oops, not balanced. So if I put a 2 there, we are balanced, okay? So now, what do I do to make my net ionic and do it a little bit faster? Well, if it's all aqueous, right? Cool, all aqueous. We are going to get rid of the aqueous that are the same on both sides. 2 NAs, and I have 2 NAs. NO3, and I have 2 of them, and I have 2 NO3s. These guys, though, come together to form the solid. So this is going to be CO3. It's an ionic equation, though, so it needs to be minus 2AQ plus Fe, and what is the charge? Plus 2 AQ makes FeCO3 solid. That is your net ionic equation. The only other type of net ionic equation that you're going to get, it's a little bit different. It happens with single replacement. So here is a single replacement situation, ladies and gentlemen. Let's talk about zinc plus HCl. Zinc metal, you did it in the lab. This is going to be a solid. All acids are aqueous. Okay. So when it actually reacts, first we check the activity series. Is zinc higher than hydrogen? Oh, there's zinc, and oh, there's hydrogen, so yep. So that's going to mean zinc ends up with Cl. We have to check our charges. Zinc's charge is +2, so it's ZnCl2, okay, plus H2, and H2 is a gas, okay. We do have to check on zinc chloride, okay. It says chlorine is soluble except with Ag, Hg, and Pb, so you know what? This is aqueous. All right, but we produced a gas. So gases and solids don't change. The aqueous do. So what I'm going to do here is first I'm going to balance this equation. I got that balanced. Then I'm going to break up everything that can break up. Zn is solid, doesn't change, plus 2H plus aqueous, plus 2Cl minus aqueous, makes Zn plus 2 aqueous. We're just breaking it down into its parts. Plus, how many chlorines do we have? 2 Cl minus aqueous plus H2 gas. So what we're going to do is we're going to look at the aqueuses and see if there's anything that's the same on both sides. Those are the spectators, those chlorines. So now we are going to have to get rid of them and rewrite the equation. Zinc solid plus 2 hydrogens, which is aqueous, makes Zn plus 2, which is aqueous, plus H2, which is a gas. This is also known as an oxidation reduction reaction. Okay, a lot of the single replacements are. So, but what you see here is you should see charges, okay? You shouldn't get rid of charges, okay? You shouldn't make them all solids. You have to indicate where they came from. We're going to do one more, and we're going to do it the faster way instead of writing everything out. I'm going to do, I have to come up with one. Oh, let's come up with one of those non-metal ones. Let's see, what did we do in the last video? I think I did, something with F2, which is a gas, plus, let's do NaI. Okay, and that's a solid. Is it a solid? Well, we're going to say it's aqueous, okay, which it is aqueous, but I'm going to give you that. So that way, the product, NaF, can be aqueous plus I2, which is, I think I2 is a solid. Nope, I think it's a liquid. You'd have to check the big periodic table. What I have here, and it needs to be balanced, I'm going to put a 2 and a 2 here, okay? What I have here is I have NaI and NaF as my aqueous. Guys, they're going to break up, and there's Na on both sides, 2 Nas. So when I rewrite this, this becomes F2 gas, nothing you can do about it, plus how many I's? 2I, and it's an ionic, so it has to have the charge, and that's aqueous. Makes 2F minus aqueous plus I2 liquid. All right, you just get rid of the aqueous that are on both sides. That is net ionic equations.